Okay, so tonight's speaker comes from uh, Thomas Evangelist. Thomas being an assistant principal of physical sciences at Brooklyn Technical High School for 30 plus years. And he's a former part-time author for the McGraw Hill Companies for 18 years. Born and raised in Brooklyn, New York, Tom currently lives in Northern Dutchess County in Brooklyn. He is a three-time Brooklyn College graduate. In 95, got a BA of chemical education and then MA of chemical education in 97. In 99, certification supervision of schools. And he is also a former adjunct lecturer at CUNY Brooklyn College. Tom's presentation tonight is titled A Breath of Fresh Air, Getting Oxygen to Other Planets so that humans can briefly inhabit space. And with that, let's give a warm welcome to our speaker.
Hi, thank you very much. It's good to be back. Okay, Happy New Year, everybody, because I haven't seen you yet in 2025 because everything's been canceled, but don't feel bad. Everything in Brooklyn has been canceled also. So it's been rough with the weather. So, okay, let's see here. Enter. Oh, I got to slide down then. There we go. Good. All right. So thanks again, Bart, for the introduction. Nothing has really changed. I'm just 2 years from retirement. Instead of the last presentation, I was 3. Not that I'm counting down, but there is the countdown clock on my desk. I left it June 30th. The other assistant principal just retired. She left me the clock. I set it to 730 days and I walked out. And that was the last day of school, June 30th. But, and you guys know me by now for the most part, but so I said, let me just do a little bit. What do I do beyond, the phone calls and emails? That stuff is the boring part of my day. But actually, if you ever, no, I don't know how many of you actually know, but I'm actually trained by an NHL goalie coach. I applied for his goalie camp and he actually took me in. And within 10 minutes, I was already beaten up. I was in my 40s. He probably just took me in to avoid age discrimination. Biggest mistake ever. I ended up doing his camp 14 times in 9 years. So talk about strength training. But this is my hobby away from astronomy. So I love it so much. I actually had a team at the school for 16 years. I had the kids design the jersey. I had a contest in the building, and this is what they came up with. But this is why I love the school I'm at. This guy here, dentist. This one here, orthopedic surgeon. 2 financial tycoons over here. So I'm always in good company. And yes, that is me smiling. We are definitely not winning at that point in the game. So also, my writing skills with McGraw Hill. I've also edited for New York City. This was a huge project, the Science Safety Manual for grades 6 through 12. And when you have to involve the FDNY legal teams at the Department of Education, this was one crazy project that took on a long time, but they picked me to do the physical science part. So that was quite the honor there. And they paid you well too. So this here, and wow, I'm not around kids. It's unbelievable. But this year, the school was given what was called the Motif Award. And it's an award for humanitarian, demonstrating humanitarian skills and doing better for society. So the school was honored 100 years of doing good for children. And the principal says, I'm not going, you go, you go. So you got a tuxedo, go. So so I ended up on not the stage at Carnegie Hall, but one of the smaller stages. But it was interesting here. I actually met the person who is Big Bird. He's with all 25,000 feathers in his all over his costume. But anyway, so it was quite the evening. And then, but this is more like it here. So every kid at my school has to pick a major, and the 3 majors that I oversee are chemistry, physics, and pharmacy. This is a great major here. The kids do the first year of pharmacy school with me at high school. And then they move over to Long Island University Pharmacy School for 5 years. We've actually had kids at the age of 22 already become pharmacists making $165,000 a year, just like that. It's unbelievable. This program, all the kids in the white coats, they're going into the program. That was actually last year's group. On the bottom left, there's that's my chemistry majors, a few of them. We were actually invited to a $1,000 per ticket event and somebody made a donation. So unfortunately for me that night as a chaperone, there was alcohol served. So I, I had to be on top of that all evening, right down to that dessert that had a sweet wine in it. So I had to make sure they didn't go to that dessert table at the Venetian Hour. And down here, and this is, of course, we're at the Rose Center in New York City, the planetarium. And actually, this young lady here on the end, the blonde with glasses, she was actually a student here at New Paltz. And when I was a guest speaker here a couple of years ago, I reached out to her and said, "Hey, let's meet up. I'll be in town." She said, "No, no, 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 none of that." Because she graduated in 7 semesters and not 8. Okay, because all these kids here, and you look at them, the kids up top, some of them have somewhere between 25 and about 44 credits, college credits when leaving high school. It's absolutely what an amazing group of kids I work with. So nice stuff. Okay, all right, and that's me. There I am, right over there at the moon. Oh yeah, oh I have to use my mouse on this one. Gotcha. Okay, gotcha. Okay, all right. So let's talk about getting oxygen to another planet. Okay, of course, let's get the obvious out of the way. All right. Time, money, and we don't have those things they had in Star Wars to transport the big stuff. Okay. So all right, but we'll work it out what is feasible, what's not, at least for today, at least today's technology. But let's just get this out of the way. Okay. It's how much you want to invest into things, it's what you'll get back. So, all right, now before I go into the big stuff, let's start with the basics, like I normally do. The 87-88 school year, and my chemistry teacher tells us, "Oh, we're taking a trip to the zoo today, and we're going to see Leo the lion, and Leo the lion's going to say grr." Okay, and that's the loss of electrons is oxidation. That's where the Leo comes in, and gain of electrons is reduction. Okay, that's the Regents Chemistry 101, although the syllabus is completely changed to September. That still holds the same. Okay, and yes, I used a toy lion. This way you guys don't get angry letters that the animals were harmed in the filming of this movie. Okay, but anyway, but we move on to the lithium ion battery, just an overview. Okay, because redox reactions, if I may, go back. Nope. There we go. Redox reactions is basically the battery. Okay, it's the cornerstone of what happens in your battery. But I put this in here, just the basics. You have a cathode, an anode, plus and minus. You have some sort of separators, a porous separator, so there can be ion exchange between the cells. Okay, you have an electrolyte. If you remember back to your Regents chemistry years, the teachers, they had what was called the salt bridge. Okay, if you had the 2 beakers with the salt bridge and the voltmeter, if you can, your teacher ever brought that in. Of course, obviously, your lithium ion battery is a little bit more advanced, but it's basically the same stuff. Okay, all the parts are the same. You need yes, electrons will move, but you need ions to move, because that's when you can get the electrical current flow. Okay, when you have ions moving, that's the electrolyte, a whole other issue. But but like your electrolyte Gatorade, loaded with electrolyte, you can actually put the wires from the light bulb in there. We do it in class, and the light bulb lights up with the Gatorade. So that's it. Your good old stuff. Basic chemistry. We're actually going to move in the opposite direction. No pun intended. Okay, actually, tonight, the opposite, what your galvanic cell can do. We're going to look at what electrolysis can do. Electrolysis, it's going to come up quite a bit tonight. So the basics is that you're going to add electricity to force something to occur. Okay, now your cell phone. Okay, and Jack ran the whole operation on his cell phone before, right? You still don't have a full battery. There's no way. But anyway, your battery in your cell phone sends the electrons in a particular direction, and it doesn't need any coaching. It just happens. Okay, one of the metals in there is more reactive than the other metal, and one metal sends the electrons in the pathway to the other metal. They have no choice. Okay, So when you plug it in, let's say this here has this cell phone, I don't know, what does it have, a 3-volt battery? Okay, it discharges, 3 volts. But when you recharge, you're sending 110 volts back in the other direction. See, it'll automatically discharge, and the battery will automatically drain. That you don't have to coach. But if you want it to recharge, you're going to need to force it to happen. And that's where the electric current from your outlet comes in to force it back in the other direction. Okay. All right. So far, so good with electrolysis. All right. Going nice and slow, not like last year when I did all that chemistry analysis. All right. Now, middle school 101. Okay. The Hoffman apparatus. You have the setup here. You have the water in the middle. You hook up an electric current to it, and you get the water to break down into hydrogen, and it breaks down into oxygen. Okay, does this look familiar? Okay, maybe we're going back, way back to middle school here. But again, water covers how much of our planet? Okay, it doesn't break down. It's a very stable molecule. Okay, it just wants to be that way. It just what it does to make it, okay, is just favored in nature. That's why we're covered by this stuff. That's why it just doesn't disappear. All right. There's other chemistry involved that keeps it together, of course. So when you send electricity through it, now you get the opposite to happen. Okay, water loves to form. Okay, it loves to cover the earth. So what does it take for it not to be water? It takes a good electric current. It takes the electrolysis process to take that water and send it back to the oxygen and hydrogen that it originated from. Okay, now you'll notice here, I'm pointing out all the oxygen because we're focusing on oxygen here. So I put an arrow on all the oxygen, but overall reaction, you do get 1 mole of oxygen for every 2 moles of water that are decomposed. And the negative sign for the E value means that we had to add energy. Okay, it doesn't happen spontaneously, but when you add the right amount of energy, it'll go. Okay, so that being said, let's talk photosynthesis because plants take up water. Okay, xylem, phloem from the roots up to the leaves, yada, add sunlight. Okay, they take in carbon dioxide and they make these energy-rich molecules, one being glucose, okay, and one being oxygen. And this is stored energy for the plant or us when we eat the plant. Okay, and the oxygen is released into the atmosphere. So we can do the same with water. If you can have a setup, the right equipment, you could use a solar panel, send an electric current into water, and you could break down water and make hydrogen and oxygen. Teacher does it right in the classroom in my school. They have a little car with the water, there's the hydrogen cell car, and the thing zips right across the floor. Okay, it's not uncommon. I've seen it a million times. So, but you could do the same thing here. Again, if you add the right amount of energy and you have the right components, you can get oxygen to form, okay, against its will. Okay. All right. Now, could we just bring solid fuel oxygen generators to another planet? We use them on airplanes. Okay, that's where you get your oxygen from on the emergency. I'll talk about that in a second here. But they're rich in oxygen. Okay, you'll notice here, SFOGs are made with superoxides that's on the left, chlorates in the middle, and perchlorates on the right. And again, what do they all have in common? If you have these oxygen-rich compounds, can we add the right amount of energy to make it break down into oxygen? And the answer is yes. Okay. But there's always the downside. Okay. That you can't just put these things on a space vehicle, and just zip over to Mars. It's a long way to go with these reactions, possibly taking place out of control. So sodium chlorate, lithium chlorate, you can break them down. But in order to do this, these are salts. Okay, if you're going to break down salts, I mean, when was the last time you melted a table salt? sprinkling on your French fries. That stuff, it takes a blowtorch to melt this stuff down. So you really need extremely high temperatures to get the oxygen out of a salt. Because, it could be done, but, it's very dangerous. I'll point that out in a second. So you've seen the movies. Okay, there's the decompression in the, the airplane. And then all of a sudden the masks fall from the ceiling and everyone has about 12 minutes of oxygen. That's the solid fuel oxygen generator at work. But as much as this stuff they have on a plane, if you have 200 people on that plane, you're only going to get about 12 minutes. Okay, for those people to have oxygen. After that, they don't have oxygen. Now, the crew, the pilots, they have the bigger tanks and so on. They get those big masks with the big, tube. Okay, they get the steadier tanks of oxygen. And it's on to the pilots now to get that plane down to 10,000 feet so you can, equalize the pressures outside and inside. And then maybe the cabin crew, they have maybe 4 extra tanks, depending on which airline you're talking about, just so that they could, assist the pilots if needed in some manner. But really, you can use them, but getting them all the way to Mars or let's say the moon, it's not likely. They're just there's just been too many negative. You have to be careful with this. There's too many incidents. 86, I don't remember this one here, but I mean, the plane didn't even leave the ground and something triggered the SFOGs and the plane burned right there while taxiing. The value jet one, I remember. This one, I believe, was the Everglades. Yeah, so this was the fire. It was, they were expired. That's what it was. They were transporting expired ones. Again, it's dangerous stuff. Now, Mir, 1997, one of the SFOGs caught fire, and they had to battle it out and space constraints, and it's just not so easy. And then ISIS actually had 2 events where the SFOGs failed, and thank God the backup systems worked. Okay, so all right, so if SFOGs are not the way to bring oxygen, then what's the alternative? Well, how about just those tanks? I mean, if the pilots have the tanks and the crew has the tank, well, hey, let's make a Tom Hanks movie out of it, Okay, why not? It just, but it happens. It just, I came home from my midterms, I believe in 1986. It was the oxygen leak on the Challenger. I got the right one. It was January of '86. Okay, oxygen, the tanks of oxygen, it can explode. But this year, this was the heart of the Apollo 13 movie. It was just that oxygen tank that caught fire. Okay, so just transporting this stuff around, the SFOGs and transporting oxygen tanks, and you're asking for it. And then there was also that airplane crash in Philadelphia at the mall earlier this year. And I said, it was a medical plane leaving from Philadelphia. And the first thing that crossed my mind, again, I'm not working for the National Transportation Safety Board, but the first thing that crossed my mind, people said they saw the plane come down in flames. The first thing when I heard it was a medical plane, oh my God, tell me it was an oxygen tank. Okay, I don't, has an official report been released? I don't even know yet. I'd have to check on that. But these things are dangerous. Okay, so let's take a look at more reasonable methods. All right, so SCORE, the spacecraft oxygen recovery system, this is a Sabatier process, and it helps you recover carbon dioxide and produce oxygen. So the carbon dioxide that's released on the spacecraft can be combined with 4 hydrogens. Okay, but once again, you need incredibly harsh conditions, high temperatures. You need pressure. You need a catalyst. Usually, the catalyst would be, in the old days, I guess, nickel. I don't know if they've made better catalysts since then. When I talk the old days, I'm talking like the 1900s, early 1900s. But you can make methane. Now, methane's not so bad. If you've made methane, that could be captured as a fuel. Okay, so far so good. And water. So once you have the water, you can then proceed with electrolysis to make your oxygen. See, as long as you capture these gases, as long as you can collect them and put them into the right channels, okay, with the right reactions, the right catalyst, you can have everything go, okay? But my question here is why such harsh conditions? And why does it take all this? Okay, and before I spoke about salt, you don't exactly just melt salt with a match, okay? It takes a blowtorch, but carbon dioxide itself, it's two double bonded oxygens to the carbon. That's a lot of energy to break those. And when this reaction occurs, you could see that negative sign there, the delta H. That means energy is given off. Okay, it's going to give off its heat. Okay, so this is it takes a lot of energy to do that. Yes, question. Yes. Yeah, hydrogen. Yes. Yeah, hydrogen is dangerous as well. And you know what? If there's that damn safety manual thing, the people who wrote and proofread it, you're not allowed to take a balloon of hydrogen in the classroom anymore, put the candle on it with the double meter stick and set it on fire. Bad, bad, bad. That is unless, of course, no one's looking. But then again, kids always have their cell phones out now. So, but my middle school teacher did that right in the classroom. Okay, right after he did the Hoffman apparatus, he collected the hydrogen right out of the tube, filled the balloon, and set that thing on fire right in the classroom. Okay, and then the oxygen, he showed how it supports burning. The piece of paper was burning, and then it made it brighter. Okay, I had great science. I still remember these things. So, but it's true, the hydrogen's no joke either. Why don't we have hydrogen fuel cell cars around? Yeah, if you get into an accident, there's a lot there to be concerned about. So this stuff here, it's flammable, except for the water. Okay, but then even then, once you've got the water, you're breaking it down into things that potentially be dangerous. So everything, that's why you have chemical engineers and physics, and they have all this way of handling these things, but still there's always a risk. Okay, but just keep an eye on this one here, the carbon dioxide, especially using carbon dioxide. We're going to come back to that. Okay, and this one here, the Bosch reactor, this one produces solid carbon with water. So at least, you can say the hydrogen is dangerous, but you're not producing methane in this case, which is also dangerous. So here, the only dangerous thing here with the reaction is the hydrogen gas. All right, and then once the water is made, you can then break it down and make oxygen. That's that electrolysis I was talking about, just like, recharging your phone, send electricity in, and you'll make things happen. And then recycle the hydrogen, which goes feed. That's right. One of your products is now one of your reactants. Okay, now we're talking efficient. Okay, very good. So now you're starting to recycle things. Nothing goes to waste if you design it correctly. What's great about this is you'll produce the water, but Martian and lunar regolith can be used as the catalyst. Okay, there's enough metal oxide present in the regolith that it can actually help as your catalyst. So now, if the Martian soil, let's say we're going to go to Mars, if the Martian soil can act as your catalyst, there's one less thing we have to put on that Imperial Star Cruiser to get over to Mars. Okay, for that trip. All right, so let's take a look at the pictures here. That is on the left, Exhibit A, if you will. Okay, that is Martian regolith. You can tell from the color, nice and rusty. And it does act as a catalyst. It gets darker with time because, just go back 1 second here. That's the carbon solid that's forming. That's the black deposit on it. So as the reaction occurs and the Martian soil acts as the catalyst, you are getting your water. You may not see it there, but the water is being produced. And the evidence is that it's turning black, and that is the carbon being produced. But you can use the Martian soil as a catalyst. This raises an eyebrow. I mean, I was just up here 2 years ago saying, fools, you'll never get to another planet. It's never going to happen. It's, this, that, and the other thing. But actually, there are some promising processes here. But this year, it's been proven in a laboratory that it works. So it raises an eyebrow for sure. Now, I think I'm actually on my last one. Here, we're getting to the end. Okay. MOXIE there's a lot of letters missing here. It's like the Mars, oxygen, in situ, recovery experiment. Okay, but anyway, they call it MOXIE. And again, the goal, bioelectrolysis, carbon dioxide, hard to break down. Okay, but if you use the right amount of electricity and you could send this reaction to form oxygen, it can occur. Okay, lots of electrons, gained and lost. As long as it's balanced, on the left you have 4, on the right you have 4, you're good to go. Okay, but why is this year promising? On small scale, at least. Okay, so Mars. Now, when you read the y-axis, please be careful. Okay, it's logarithms. Okay, so you go from 1 to 10 to 100. Okay, and just 2 little jumps, but. So it looks like the other gases are quite abundant, but they're not. Argon is gone. I mean, nitrogen, nothing. Oxygen, okay. Carbon monoxide, not even. But look at that carbon dioxide, 95.9%. So now you have your carbon dioxide source. Okay, now you have your Martian regolith to serve as a catalyst. There's 2 ingredients right there. So it's looking good. So this year has been used already. And with this device, let me see if I can just get my dates right, because I get a lot of news and the kids in class are always telling me about the things. But I think it was 2021. I think this device was used on Mars, and they were able to make about 12 hours-ish or so of oxygen for a small animal. Okay, not humans, not a colony of humans, under a dome or anything like that. But they were able to get enough oxygen to be produced. But again, with everything I do, there's always the good with the bad, and there's some problems here. Number 1, okay, carbon dioxide is needed to keep Mars warm. If you remember my weather report from Mars 2 years ago, if the high today is, -40 Celsius, today's low, -70. Tomorrow, -40 and -70. Okay, so not only have we started to modify what's happening on Earth weather-wise and temperature-wise, but now we're going to start playing around what's happening on Mars, okay, with mass colonization. And then, of course, the one thing to always look for in your telescope, a nice ice cap. And it's actually dry ice caps. Okay, with the carbon dioxide's locked up. So if it's seasonal and the ice caps come and go, is this carbon dioxide going to be available? Okay, again, the energy, the cost of the catalyst. Well, you could debate the catalyst, but at least in MOXIE, you have to provide your own catalyst. But it's always the cost of things. I brought that up earlier. Okay, and then it depends on where on Mars you are. Okay, pressures can change, atmospheric pressures can change depending upon your location. And that's why if you bring your hockey team into play the Colorado Avalanche, you want to get there the day before. Okay, it's so you can adjust for that mile high kind of thing. When your sports team travels to Colorado to play, okay, you need to bring them in a couple of days earlier so that the athletes can get used to the change in pressure. Okay, so it does make a difference. Okay, different elevations do make a difference in pressure concentration. Okay, but it is promising. Like I said, a couple years ago, I was like, nah, you'll never get there. But there was some, some potential things. I know the kids in school, they did a project with another astronomy teacher, and just for laughs, I said, so what'd you conclude? Kid says, I think I'm about 300 years from discovering how we could put this all together. So I said, yeah, tell me when you figure it out. Okay, by then, who knows? But all right, very good. Well, thank you very much. That was Any questions? Thank you. Any questions? Yes, in fact, it's just to have a generator put in at my house, like the specs of exactly where it's going to go. You can't carbon monoxide, we had a big power outage July 3rd. We had a tornado come through Northern Dutchess. And I'm saying to myself, in the house, carbon monoxide, the meter was up. And it was like 3 parts per million or whatever it was. And I was like, wait a minute, how is that possible? I don't have any electric, the furnace is off, and I have nothing else that runs burning gas in the house. And actually, this carbon monoxide actually does come in. So yes, it is a concern. Not that it was jumping up and setting off the alarm, but if it's always reading 0, 0.003 is like, whoa, okay, it's a reading. I was like, wow, the thing really worked. But yeah, it is a concern. Carbon monoxide is definitely a concern. Yep, yep. How much power was needed for the Moxie to go to proceed with its reaction? And offhand, I don't know how much power it was receiving, but if I'm not mistaken, did we not have the rovers? They were working off solar power for some time. So, and so I guess you are getting some sunlight there, and if it powered the rovers, for a long enough time. I don't know, how long did those 2 rovers go for? I don't even, are they still going? I don't even know. So yeah, I think that probably, but all I know is that the big news for me was when Voyagers finally left the heliosphere and they were but those 2 rovers I've forgotten. But yeah, there is enough sunlight, I guess, but the exact amount I don't know offhand. But that's where your catalyst comes in. Okay, so that if you have the right catalyst, yeah, you can greatly reduce the activation energy, and it just takes a little bit less to get things going. Okay, so for sure. Yep. Or go ahead. Right. The question is there's a concern about changing the Martian climate? What is it? When you breathe out, you're putting the carbon dioxide back. That is true. But here's the thing. If your rocket goes to Mars, it gets there, we launch off because of liquid oxygen. Okay? If you're going to get humans back, you had better have that oxygen to get back home. Okay, so what's it going to take to refill? You're not going to stop off at the Exxon on the corner and just, liquid ox all the way back. I'm assuming people want to come home and see their loved ones. But yeah, that's another problem. It's just, how much would we have to modify? Okay, so Paul, what was your second question? I mean, so the question is if we have enough farming and enough plants and producing, undergoing photosynthesis. I mean, I guess if you could pull that off, but yeah, that's one hell of a project. That's one hell of a project, but yeah, you would need quite a bit. So, the deforestation, it cuts back on our oxygen. But there's also the other argument you hear every now and again. The kids bring it up, and it's interesting. If they could research it, go ahead. But they say, but how about the carbon dioxide that we've released? Hasn't that helped plants to grow around us bigger and better than it would have been? That's an interesting question. It's thought provoking, and but as to quantify things, I wouldn't know. But what would it take? Yeah, you would have to have one hell of a settlement of vegetation to generate a lot of that oxygen. Don't forget now what it took, to get us to where we are today with our atmosphere, and so yeah, plants have been around longer than humans have. That's for sure. That I can guarantee you. Yeah. Any other? Yeah. Go ahead. Curiosity and Perseverance. There were 21 rovers on Mars, and Perseverance and 2 are functioning. So the other ones, yeah, so the other 19, one got killed in a dust storm. Okay. What are they, those little devils? I forgot what they call, dust devils. Those little tornadoes of dust. Yeah, so that's it. But yeah, Curiosity and Perseverance. Okay. Yeah, it's just, when you hear enough of these things in astronomy class, it's just so much to remember. That's why it's just so much easier just to log into NASA. And it's like you wouldn't believe, by the way, when you log onto their website, just how many missions are out there now. I mean, I was excited about going to Europa last year. The Europa Clipper, because all the chemistry involved. I was like, whoa, look at this thing. But that's actually just like 3% of, not even 2% of what's up there now and what's being explored. And in fact, I think the latest news, like we've gotten to the closest we've ever gotten to the sun. As you know, if you don't read these things every day, it's just so much science so quickly. It's been unbelievable. So that's why, back in the day when I was teaching astronomy in school, I had the astronomy magazine, Sky and Telescope. You had to read Science Times, New Tuesday. If you didn't keep up, and then the kids were all over the internet, and even with reading all this stuff, they just blow you away with how much information they're constantly finding. Other kids like on the bus. I'm going home from other schools, and they're using their phones to X, Y, and Z. No need to describe, but and then our kids, like I said, my kids on the bus, you see them from school, and they look, the journal monthly for science or whatever it is, and I'm like, ay. But the internet, they just keep all over it. So, but yeah, so much is going on. Yeah, but NASA's website is the way to go. Okay, other questions?
Question.
Oh, question.
It seems to me that I saw recently a YouTube from a reliable source saying that there is actually, there may be a fairly significant aquifer on Mars beneath the surface. And so I assume if that were true and it were accessible, that would make a huge difference to this.
Oh, yes. So many times when we look for water on other planets or moons, the knee-jerk reaction is search for life. There's water, search for life. Water, search for life. You wrote a clipper last year. Let's look for life. And my whole presentation last year was looking for amino acids. What would we look for to find amino acids? And now all of a sudden, hey, how about the oxygen we need to stay there or go there and come back? So yeah, that is a very good point, that the finding water, they would serve double purpose, not only to look for life, but also if you had to travel, that's your water source to get back to provide oxygen. A lot to think about. Question? Okay, so the question is, would this work with Venus? Okay, so Venus wouldn't have the regolith that has what Mars has is a metal oxide, iron oxide, that serves as a good catalyst. Okay, Venus does have a lot of carbon dioxide, and the greenhouse effect on Venus is incredible. Okay, has a lot. The carbon dioxide is there. I think I'd have to think a little bit differently. I know the surface of Venus is very acidic. I don't know how that might play into these reactions, but the pH there. Yeah. Jack is making reference to his book on the on Venus. But that would be interesting. There is the carbon, but you have to find the water, because if you don't, now you have to transport everything. And then what is Venus? 0.3 AU from us, whatever it is. Yeah, plus the surface is hot. Jack pointing out that the surface is hot, so that could be your catalyst, I guess, if there's your temperature. But the water, yeah, the water, yeah, on such a temperature. Whereas Mars, I hate to almost say it, it's almost more reasonable at -40 to -70 Celsius. That sounds ridiculous, because humans are basically built for 40 Fahrenheit to 80 Fahrenheit. Okay, that's about it. Okay, but then to go into these other climates, yeah, that would be something. But yeah, Venus, nobody really talked about it, and I also ignored the moon today as well. But the moon doesn't have the water, but Mars. Well, it does. Oh, does it have? As I'm saying, things change. Have they found the water? No, appreciable amounts. Craters. Okay. Okay. Where sunlight doesn't get, they found. Okay, indications of life. Okay. All right. Yeah, but Mars has those evidence of lakes and streams and whatever it was. And so, but yeah, it's interesting though. So like I said, a couple of years ago, I said, the hell with it. You're never going to get there. But actually, at least the oxygen part, if the water's there and you have your catalyst, and it depends on just how much you have to transport. It's a lot of factors. But yeah, Venus, it didn't come up as a candidate, even though it has that atmosphere. Yeah, and so Bart is just pointing out, those of you at home, even if it's there, you still have to access it. Under conditions, you'd have to be able to contain it. Hard to do, but that's why we have engineers. Hey, they're already paying my pension. Let them figure it out. Good luck to you guys. let them figure it out. But yeah, that's why we have the kind of school that we do. It was built to be a college, so basically your junior and senior year, it's all college course. So, so I say, let the kids in the lower right figure it out. They're the kids. So, but yeah, it's interesting, but it's definitely a long-term project if you really want to put time and money into it. But who knows? See what happens. Okay, other questions? Okay, yes. What do they use on the ISS currently? I thought it was the Electron system. I thought that's what at least it was in 2000. I guess on my notes, it was in 2004. I don't know if they've changed it there. They have the Electron oxygen generator system, and Electron has a K. That means the Russians, it's probably Russian made. So, but I don't know. As of today, I don't know what they use offhand now, but I came across the famous fires from SFOGs as, oh, there's the one from the Everglades. Yep, okay. And then famous ones, Apollo 13, the movie, that's been a good 30 years. But yeah, I don't know offhand what ISS is now. No. All right, I'm going to call this one complete then. If you have any further questions, okay, you can always email me. You'll get a reply message. Hey, I'm not reading my email till August 25th. Okay, so yeah, that's when that countdown clock will read 6:75 on my desk. But anyway, but if you need to reach out, that's my email. Hey, let's hear it for Jack. Okay, I was here at 6:56. He's like, I can't get in. Okay, we have full access. So, all right, thank you very much for having me again.
Right, wonderful. Thank you so much. I just want to note that also the other problem with Venus is I forget what the pressure on the surface is, but it's like 8 or 9 atmospheres, like being at the bottom of the edge. Yeah, Venus is not hopeful. Thank you all. Appreciate it. Let's see. For Jim, we've got, I think it was 13 people. Looks like, did we pick up 1, 2, 3, 4, 5, 6, 7, 8, 10. 14 people in the room, Jim.
Okay, thanks.
Thank you. All right. With that, we will call a close for this evening. See everyone next month. And thank you all for attending. Oh, I was supposed to ask one other question, Tommy. I think we're still recording because I'd have to shut it off. Is the scenario of oxygen generation as provided in the movie Spaceballs realistic? The Schwartz would have to be with us. Yes. Okay. Got to switch it from suck to blow. All right. Thank you very much. We will stop the recording somewhere and I can't find it. So I'm just going to end the meeting.